Good morning.
Good morning, sir.
Good morning. Let's wait for another 1 minute. Then we'll start it.
Sir, today we are doing practical or lecture.
We will continue this CAM part so that it will get over both in theory and practical. So you might find that it is the continuation of our practical class, right? So both will be covered. The module 4 is your CAM and follower mechanism. So that is also getting covered, and practicals are based on the module 4. In this way, both will be covered as you are drawing on the drawing sheet, or later on you will fare it, right? You just take it in notebook as a rough, and later on you can fare it. What is important is to understand the procedure for drawing the CAM profile depending on various factors like angles, type of motion, type of follower, etc. That is important. So let us continue then. Are you all ready for it? If you pay attention, then you will definitely enjoy it. So today we are going to solve this example, which is based on CAM profile, okay, with given conditions of various angles like angle of rise, return, dwell, then condition of motion, which type of motion is there, which type of follower is there, okay. So all these factors will influence the CAM profile. Okay, as you know that how we incorporate these input parameters in that, you might have got some idea by the previous examples which we solved in the classroom. So you read it, say for 5 minutes, try to capture the given information, okay, and then we will proceed further. So in 5 minutes, I will be back. Means I'm here only. You can raise your queries also if any. Otherwise, you read it and copy the numerical. So I think that fourth module will be covered, right? Fourth module will be covered today, or by taking one more lecture tomorrow. We can finish it off. In this way, 3 modules will be covered of the syllabus, and the that is the next module, that is module 2, we will start in the next to next lecture. That is our plan. If we see that 3 modules are covered, then only 50% syllabus is covered till now. Let us see how we can do it. Again, I will open a window of assignments. Those assignments are nothing but your term work, like drawing sheets based on your ICR method, your relative velocity method, relative acceleration method. So these drawing sheets you can prepare using the KOM video lectures. Okay, same problems you have to solve. Okay, and submit. I'm not asking new problems. Same problems you have to solve again on drawing sheet and submit it. Let's keep it simple. So copy down the problem. Done.
Sir, 2 minutes.
Okay.
Good morning, sir.
Good morning.
Sir, we can't hear you.
Is it n- now? Can you?
Yes, sir.
Okay. So, Samuel, you check system at your end. So, I will read this problem for you. So, what is the problem to draw the cam profile? Okay, with a minimum radius of 25 mm. You know that we call it as base circle radius. Okay, rotating clockwise at a uniform speed is to be designed to give a roller follower type of follower is see now in earlier problem which we have solved the follower was a knife edged follower. Here it is roller follower. So how the construction will change in case of roller follower, we will see that at the end of a wall rod. So it is a mechanism wall rod which is operated using a cam and follower. So motion is described as follows. First follower will raise, okay, through 50 mm, means it is the lift of the follower, that is called as H. We have denoted it by H during 120-degree rotation of the cam. So as during this rotation follower is rising, it is nothing but your angle of rise that is called as theta 0, 120-degree, means the motion of the cam begins with rising of the follower, okay. After this 120-degree, there is this condition to keep the wall fully raised, means to keep the wall in its top position through next 30-degree, means it is your first dual period during which the fall does not fall or does not either rise further as it is at its top position. Next is to lower the wall during next 60-degree, means during this 60-degree the follower will lower down. So this 60-degree is nothing but your angle of return. We denote it with the help of the symbol theta r, angle of return. Next is then to keep the wall closed during rest of the revolution, means when the wall comes to its bottom position, when follower is at its bottom position, wall will remain closed. Okay, so this, it is your second dual period equal to 150-degree. So you can call it as angle of dual. Okay, second. Then diameter of the roller is given. You know that a roller follower is being used. So diameter of roller is also given. Roller follower, how it looks like, it is like this. इस तरह होता है रोलर फॉलोअर, और जो रोलर होता है इट इज इन कांटेक्ट विद द कैम सरफेस. So this roller diameter is also given as 20 mm. Okay, and because of this roller, there will be changes in the construction of cam profile. You have to make use of this diameter 20 mm. Okay, now where it is adjusted, we will see while drawing the actual cam profile. And the diameter of the camshaft is 25 mm. So sometimes this camshaft diameter is same as the minimum radius of the cam. Suppose if minimum radius of the cam is not given, and camshaft is given, camshaft diameter, you can take that. Okay, sorry, what is it? It is, in this case it is not equal. Camshaft diameter is 25 mm, means its radius will be 12.5 mm. Okay, draw the profile of the cam when. Okay, so first is, again there are two conditions. First one is of radial follower, that the line of the axis of the follower will pass through the center of the cam. It is one thing. Second is that the follower is offset. Now here it is given as it is offset by 15 mm. So you know that in case of offset follower, how you first locate the position of follower as tangent to the offset circle, and then you continue the construction. Okay, but apart from offset and radial conditions, what has also changed is nothing but the type of follower, roller follower. So because of that also we have to make some changes. So again, for these two cases you have to draw the cam and follower. Next is the displacement of the valve, which is directly connected to the follower. So you can say displacement of the follower while it is being raised or lowered is to take place with simple harmonic motion. Type of motion is simple harmonic motion. So you know how to draw the displacement diagram in case of simple harmonic motion. In earlier problem it was uniform velocity. It was the motion with uniform velocity. Here it is with simple harmonic motion. Determine the maximum acceleration of the wall rod when the camshaft rotates at 100 rpm. So we already have the formula for calculating the maximum acceleration during simple harmonic motion. We will use that formula. You just note down that rpm is 100. Draw the displacement, velocity and acceleration diagrams for one complete revolution of the cam. So this is also we have seen how the velocity and acceleration diagram will look like in case of simple harmonic motion. Okay, just for a purpose of relook, I will show you the velocity and acceleration diagram in case of simple harmonic motion. See, is simple how it is the displacement diagram, then velocity diagram and acceleration diagram look like this. Only you have to draw the same it, you have to draw it in same way. Just take care that here whatever is the amplitude is more and here amplitude is less. Okay, it will depend on what is your angle of return. Okay, based on that, similarly you can draw the acceleration diagram and you can take the amplitude by the calculated values. तो कितना एंगल ऑफ राइज में कितना मैक्सिमम एक्सेलरेशन है, ड्यूरिंग रिटर्न हाउ मच इज द angular sorry acceleration of the follower. Using those values you can vary it, like you can make one short and one long, like this you can draw it. So here you can see that below the displacement diagram now you have also need to draw the velocity diagram. So you will लीव सम स्पेस हियर, यहाँ पे आपको कुछ स्पेस छोड़ना है इस डिस्प्लेसमेंट डायग्राम के नीचे, so that you can draw the velocity and acceleration diagram also. No need to draw it with proper scale. Just by looking at smaller and larger one, you can make one short and one long. If it is less, then make it less and make it long, like this. Okay, so now let's go to the problem and see how we can solve it. You noted it down, this problem we have solved. So you have noted it down, write down the given data.
Yes, sir.
So it is your given data, you will take it. Again, it is same thing. No, okay. Yes, 120, 30 degree. First it was 60 degree. Okay, it is changed, but here this one is mentioned wrong. What is given, which type of motion is given to us is simple harmonic motion. The motion which is given to us is simple harmonic motion. Okay, even during rise as well as during return, it is not of uniform velocity. So these are the given data to us. We will draw the displacement diagram first, and below displacement diagram you also need to draw the velocity diagram, acceleration diagram. So you keep space below the displacement diagram. Okay, again, so you draw the rectangle like this, whose height is necessarily equal to the value h, that is the lift of the follower, which is given to be 50 mm. Height must be 50 mm, but length you can select anyone. Okay, so as you know, we divide the angle of rise into six parts. Okay, generally we divide into six parts. Similarly, angle of return is divided into six parts. So better you take this length as 60 mm and this as 60 mm. You can decide the length for dwell period as any length, because we don't have to do any construction here. Okay, you can keep it of any length. Similarly, dwell period too you can keep of any length. Okay, so draw this, then we I will tell you further the process. Okay, say in 3 minutes you do it. Please put your attendance in chat box. All of you, do not forget to put your attendance there. कंप्लीट हो जाए तो बताओ मुझे.
Yes, sir.
Okay. So you know that this angle of rise is divided into 6 parts, and during the rise there is simple harmonic motion. Okay, so for simple harmonic motion we know there is some different construction of displacement diagram. In case of uniform velocity or constant velocity, you just join the lower corner with the right upper corner diagonal. It was so simple in case of uniform velocity or constant velocity. Okay, but as given to us is simple harmonic motion. So for simple harmonic motion, what is the method of construction? You know that we draw a semicircle taking h as diameter. So take h as diameter like this and draw a semicircle. Then this semicircle is divided into same number of equal parts, that is 6 parts. Okay, as angle of rise is divided. So this semicircle's angle is 180 degree. So if you do its 6 parts, then 180 divided by 6 will be 30. So 30 का एक पार्ट होगा. So you will do it like this. ये हो गया आपका 90 के 2 पार्ट्स. अब 90 में आपको 3 पार्ट्स करने हैं. ईच वन विल बी ऑफ 30 डिग्री. So these are 3 parts. Here also you do 3 parts. You can use the protector. What it is called as protractor. Okay, to mark the angle exactly. 30 degree, 30 degree, and this is 30 degree. And then you can number it in same way like this 1 2 3. You will start from the bottom numbering because the follower is rising, so number should rise like this 1 2 3. Then this one is 4, this one is 5th, this point, and this is 6th. Now in our case you will find that even in return stroke there is simple harmonic motion. So for return stroke also we have to draw the same semicircle, but as it is a return stroke. Okay, you have to start numbering from top to bottom. Okay, so 6 is at top here, then after 6 you will number the 7. We will use the same semicircle, right? Same semicircle for return stroke also, no need to draw it separately. After 7 then it is 8, then after 8 it is 9, like this. Then after 9 it is 10, and after 10 11, and 12 will be at the point of 0 here. Okay, now what you do, so from this point 1 you have to draw a horizontal line till you meet the vertical line 1, like this here. Okay, so here which point you will get, you get the point 1 dash here. Then similarly from point 2 you draw up to this, it will be your which point, this point will be
2
your
dash.
2 dash. In this way you can extend the point till its vertical line. So you can see at point 2 here, point 10 is also there. So you can extend same line, you can extend same line till vertical line 10 here. So here you will get the point 10 dash. Here you will get the point 10 dash. Similarly here with 1 11 is also there. So this line can be extended. This line can be extended to 11 dash, vertical line 11. Here you will get the point 11 dash. Similarly 9 and 3. So the extend is, find point 3 here and point 9 here. Okay. Then 4 and 8. So 4 point here and 8 you will get here. Here 5 and 7. So okay, 5, and here it is 7. Later on, after getting all these points, after getting all these points, you just join a curve with a smooth curve which is passing through all these points. Okay, up to point 6, like this, up to here. So it is your displacement diagram. Then here you can follow the vertical line up to this point, and then again you start joining these points up to 12. So it will go like this here. In this way you complete the displacement diagram. Getting it? Suppose if it was given that outstroke with simple harmonic motion but return stroke with uniform velocity, say simple harmonic motion is not there, so in that case then you don't need to draw the semicircle for return stroke. For return stroke, which type of motion is there? That is uniform velocity. You know that for uniform velocity you just join the corners with a straight line, like this. So your displacement diagram will be modified if a different motion will be given for return stroke. Okay, so you draw it, say again in 5 minutes, then we will see that how to draw the cam profile. Okay, and below this diagram you will leave some space for your velocity diagram and acceleration diagram. So do it. If any doubt you can ask. I am showing displacement diagram a little bit dark, okay, and keeping other construction as faint light.
So we are taking 1 centimeter each for 0 to 6, correct?
Yes, yes.
Should we take less than 1 centimeter for 6 to 12, or 1 centimeter is also fine?
1 centimeter is also fine. If you want, you can take 5 mm. So that will save some space for you. 5 mm, right?
So, but if we take equal, it's okay, no? It's not wrong, correct?
Equal you have to take. If you don't take equal, then it will be wrong. This you have divided into 6 parts. These 6 parts are equal in length. Please keep in mind.
Yes, sir. But angle of rise and angle of return should,
They
angle of
can
rise is greater than angle of return. So, should we take 6 to
no
12 small, or even equal is okay?
equal is okay because this length does not matter, right? But whatever length you take, you divide it into equal parts. You can take the same length. We are not drawing it proportionally. You are right that angle of return is less, but we are not drawing it proportionally lengthwise. Okay, we are just keeping this h to be strictly as 50 mm, because when you will transfer these distances at equal distances on cam profile, that will be reflected on cam profile.
Okay, sir.
Okay, it does not affect. If suppose we draw it with proportions, then the diagram will look something else, but that will be a correct diagram. But as an engineer, we can also understand this diagram. Okay, so we can take proper meaning from it, which we are drawing. So no need to go for scale version.